All right. So I want to give some context for where we're going with this average rate of change stuff, and sort of what we're going to start looking at when it comes to calculus. So let's look at this problem here. We have the height in feet of a baseball, t seconds after being thrown straight upward, is given by this function here. H of t equals 36t minus 16t squared. What I want to do is I want to estimate the speed at t equals 1 second. Right? After 1 second, or 1 second after being thrown, how fast is this moving? Well, how do we do that? Well, this average rate of change gives us a way to do this. So we could say, well, let's look at it when t equals 1, the height of the ball is 36 minus 16, 20. When t equals 0, the height of the ball is, of course, 0. And so our average rate of change here would be 20 minus 0 over 1 minus 0, which is 20. So in that first second, the average rate of change is 20. This should be feet per second. Okay? But I'm really interested in how fast is it going at 1 second. This gives us a way to estimate it, right? But let's try and get a little bit better of a picture because, experimentally, we know that if we throw a ball up in the air, it's going to come back down, which means as it's rising, the acceleration due to gravity is slowing it down. So it's probably not 20 feet per second. How do we get better? How do we get a better estimate? Well, what we do is we just shrink the interval of time that we're using for the average velocity. If instead of looking from time 0 to 1, maybe we look from time 0.5 to 1, right? So if we compute this, we'll find out that delta H over delta T, right, which in this case would be H of 1 minus H of 0.5 over 1 minus 0.5. I won't plug all these numbers in here because this is just going to get a bit messy. But this is going to turn out to be 12 feet per second. So this gives us a little bit better of a picture. Right? So let's say here the interval of time here, this is the interval from 0 to 1 is our estimate. Here we're using 0.5 to 1. So we're sort of narrowing in on 1. Let's narrow in some more and look at 0.9 to 1. So now we're taking the average velocity over just 1/10 of a second. Right? So if we do that, delta H over delta T, which in this case, again, is H of 1 minus H of 0.9 over 1 minus 0.9. Okay? In this case, we're going to find 5.6 feet per second. So what does this tell us so far? Well, it tells us that we still have no clue what the velocity is, or the speed, because these numbers are so different. But it does tell us, we do know that this is the best guess we have so far. These two are wildly off, right? Because again, we're trying to narrow in on what exactly is the speed at 1 second, right? So the smaller the interval we use, the better picture we're going to get for the velocity at that time, or the speed at that time, because like I said, we do know that the ball is constantly slowing down. So we're sort of using less and less of the changing speed here. Right. So just to give you a couple others, if we look at the interval 0.99 to 1, 0.999 to 1, and 0.9999 to 1. I'm not going to write out the full fraction like this time. Right. In these cases, the average speed will be 4.16 feet per second. Okay. So again, this is our best estimate yet. When we move here, we get 4.016 feet per second. And if we do it one more time, we get 4.0016 feet per second. Right? So again, we're just doing the average rate of change of h over these intervals. Okay? So with this in mind, now we can hopefully make a much better guess as to what the actual speed is at 1 second, right? Because here, we're down to, what's this, 100,000? We're down to 1/10,000th of a second that we're taking the average velocity over. So that's like a snapshot in time, right? That's less than a frame of a video, for example. So, we're basically taking the estimate of the speed there. So what we want to do is look for some trends in these numbers and say, well, where does it look like we're kind of trending to? Well, so what we can say here is, it appears that the speed is, what do you think is a good guess? I'm going to go with 4 feet per second at this time, 1 second. Right. So this is just sort of an idea of where we're going with the average rate of change. So hopefully that helps, and see you in the next one.